Another Earth could be as close as our nearest star system.
We're right on the threshold of being able to find these planets.
There could be nowhere in the universe.
We have a fantastic goal yet for the next generation, which is to find planets that remind us of home.
I believe we're right on the brink of having the technological capability to actually answer a question that humanity has been asking itself for the last 2,000 years.
Another Earth could be as close as our nearest star system.
We're right on the threshold of being able to find these planets.
There could be nowhere in the universe.
We have a fantastic goal yet for the next generation, which is to find planets that remind us of home.
I believe we're right on the brink of having the technological capability to actually answer a question that humanity has been asking itself for the last 2,000 years.
Another Earth could be as close as our nearest star system.
We're right on the threshold of being able to find these planets.
There could be nowhere in the universe.
We have a fantastic goal yet for the next generation, which is to find planets that remind us of home.
I believe we're right on the brink of having the technological capability to actually answer a question that humanity has been asking itself for the last 2,000 years.
Another Earth could be as close as our nearest star system.
We're right on the threshold of being able to find these planets.
There could be nowhere in the universe.
We have a fantastic goal yet for the next generation, which is to find planets that remind us of home.
I believe we're right on the brink of having the technological capability to actually answer a question that humanity has been asking itself for the last 2,000 years.
Another Earth could be as close as our nearest star system.
We're right on the threshold of being able to find these planets.
There could be nowhere in the universe.
We have a fantastic goal yet for the next generation, which is to find planets that remind us of home.
I believe we're right on the brink of having the technological capability to actually answer a question that humanity has been asking itself for the last 2,000 years.
Another Earth could be as close as our nearest star system.
We're right on the threshold of being able to find these planets.
There could be that is planets outside our solar system. The vast majority are gas giants, which are easier to find than small terrestrial planets like our Earth.
To build instruments to analyze those Earth-like planets, we have to anticipate ahead of time what the chemicals might be in that Earth-like atmosphere. For that reason, we need theory, we need models.
Victoria Meadows is in the planet modeling business. She heads up the Virtual Planet Laboratory at Seattle's University of Washington. The group, spread across institutions around the country, builds worlds that may exist in the yet unexplored universe.
The Virtual Planetary Laboratory allows us to simulate what planets might look like from space and what their environments might be like in advance of actually discovering these things out there in the universe. So it allows us to explore what planets might be like.
In the Virtual Planet Lab, fantastic worlds can be built, like a science fiction novelist with a supercomputer as a writing partner.
So we can take something that's like the Earth, but we whip away the sun, and we replace it with a star of different size and temperature. So what we've done with the Virtual Planetary Laboratory is modeled planets that started out as Earth-like and put them around stars that were much hotter, with much stronger UV radiation, for example, than our own sun.
The models can produce bizarre alternate Earths, filled with plants that are bright red, orange, or even pitch black. Photosynthesis can vary greatly depending on the light of the star that's shining on it.
Planets around F-stars, for example, where the light from the star is much bluer, the plants there will tend to absorb more blue light, and so those plants could potentially be more likely to reflect red, orange, and yellow light, and so will appear red, orange, and yellow to us.
Plants on a world around weaker stars could evolve their coloration to use every bit of energy falling on them.
If you go down to much cooler stars than our sun, to M stars, plants on planets around M stars might in fact be black because they want to absorb as much light as possible to do their photosynthesis and to feed.
And then there's the water world planet. a theoretical Earth circling a volatile M-type star that constantly hits the planet with outbursts of deadly radiation.
And how does life cope on the surface of that planet? Is it possible to have life even when you have a flaring M star? It turns out that you can actually